asymptotes, it's important to mention that there's no function we can use on our calculator to just find the asymptotes of a given function, but we can graph, which is incredibly helpful, and we can do some useful checks once we've calculated algebraically where we think the asymptote should be. So I've got a rational function, a reciprocal function over here plotted on my graph. Now it's worth mentioning, okay, I can see, I suspect there may be asymptotes, but I don't know that for sure. I need to check, although visually it makes sense that there would be. So looking at this function, I'm going to first think about the vertical asymptote. So it's looking to me like there's a vertical asymptote somewhere here. The first check that I can do, if my asymptote might be a nice whole number, I can simply open my table of values by pressing Control T. And I can scroll through my x values, and I can see if anywhere in the y values over here it says undefined. However, looking at the graph, the asymptote looks to be between sort of 0 and 1, and my table of values only gives me integer values of x. So this is only helpful for looking up the asymptotes if it happens to be a convenient integer value. So that's not going to help us too much. Okay, so algebraically, I can think about where the vertical asymptote is on this function. That's going to occur when the denominator is equal to 0. So then we're going to try and divide by 0 and it will be undefined. So that's going to be at a value of x is equal to 1/2. So I have to calculate it algebraically, but I can now check if that's correct on my graph. So I want to look up if there is a y value at x is equal to 1/2. For this, I'm going to use the trace function. The trace function, if I go to Menu and Trace and Graph Trace, this will allow me to find the y value or the coordinates at any x value. All I need to do is I just type in my x value. So I'm looking for 1/2 or 0.5. I hit Enter, and it gives me my coordinates down here. And look, we can see it's undefined. So if I had to find the asymptote, the vertical asymptote of a function, I can do my calculations, and then I can graph the function and check. The other type of asymptote that I want to think about is the horizontal asymptote. Again, looking at this function, and from what you know about reciprocal functions, you may suspect that there is an asymptote. And if there's a horizontal asymptote, looking somewhere around here, that means that these lines will never intersect. So the blue function will never intersect wherever this horizontal asymptote is. But to check for that, if I just plot where I think the horizontal asymptote is and keep zooming out and I just don't find an intersection, that's not really convincing enough, because what if I just haven't zoomed out far enough? Looking at this function, from what I know about my behavior of functions, I can see that as x tends to infinity or minus infinity, this whole function will tend to but not reach 3. So initially, I may want to plot another function at 3. Okay, that looks like it could be reasonable, but again, I don't know if I just haven't zoomed out enough to find the intersection. So we need to do something different. To do that, I'm going to open a new page on my calculator. And this is going to be a calculator page this time. And I'm going to try and solve the equation when my function is equated to 3, where I suspect the asymptote is. If that has no solution, no intersection of the graphs, then I've probably got my asymptote. So I'm going to go to Menu, Algebra, and Numerical Solve. We'll talk more about numerical solve in a different video, but it basically solves an equation that has one solution and gives you back that solution. So I need to type in my function, which was 1 divided by 2x minus 1 plus 3. Okay, and I'm trying to solve that equal to 3. So I type in my entire function, and my entire equation, comma, and then what I want it to solve for. So I want it to solve for x. I close my brackets, I hit enter, and I get no solution found. So we can see, equating my original function to 3, they do not have an intersection, which again is a good check that the asymptote that you found is correct.